Alright, so this is my favorite PETG from California Filaments. It's black. I like it because it prints really well and it's fairly inexpensive, especially if you buy multiple reels at the same time. So I use it mostly for printing these Star Wars Outer Rim game dashboards. So they help you keep all your... There's a Star Wars game where you have a bunch of cards and some other cards and you have to slide them around. And this helps keep everything neat and tidy so it doesn't get knocked around. So the benefit of PETG for this is it's flexible. And so when you connect these and disconnect them using these dovetails, they don't get messed up like they might with PETG, with PLA. There's it on the ground there. There. So then that makes it a full unit. And anyway, so I've been using PETG for this successfully, and it's less expensive than the black PLA I'm using. Here's an example of what I used the black PLA for. This is a dice tower that didn't print all the way because I ran out of filament. I printed this a long time ago before I was more aware of how much filament is left on the reel. In any case, I keep it around because this is my example. So this is super rigid, printed in PLA. So I was trying to see if I could print this in this PETG because it's cheaper than my PLA I'm using for this. So I did a couple tests. One of the problems with this product is that it takes over 10, 11 hours to print. So it's not a very efficient use of the printer if I don't make much money off of it. So I'm trying to speed it up and use a cheaper filament. So I decided to try the PETG. I did a couple tests. The first test I just printed the base of it. So this isn't rigid, then you're rolling dice on it. It's not something that I want to sell. I want this to be rigid, so it feels like it's solid. So this is the first thing I did. I'm printing this with 0.3 layer line, which I'm also doing on my sabak pot tray, which that seems to be stiff enough, but this is not very stiff because to speed things up and use less material, I only have a 20% infill on this. This is 20% infill and it's fine and rigid. This is at 0.3 layer lines. This is too flexible and squishy. So this is 0.2 layer lines, a little more rigid than this one, not quite as squishy, but still too flexible. So that's the problem with the advantage of PETG for this is it's flexible, but for this I don't want it to be flexible. I want it to be rigid. So I think PETG is out for this product, which is too bad, but that's the way that goes. But in the process of doing this, I started printing faster. So I have been printing PLA at 3,600 millimeters per minute, and PETG I've been printing at 3,000. So this I printed at 3,600 and it seemed to print fine. So I'm going to try printing these at 3,600. It's not a big change. It's about see, 3,600. It's about, well, when you print something for an hour, it takes about 2 minutes less. So it's about three. What I calculated was actually printing something. It's about 3.7% less time. So, but these take hours to print. So 3.7 or almost 4% will save 10 to 15 minutes off the time of printing something. But the big test is for printing faster is if I can print this bed adhesion and layer adhesion test angle, and if it's strong, then it's fine. So that's what we're going to do first. This only needs 10 grams of filament to print, so we're going to use one of our remnants to print that. I'll get the printer set up and we'll try that and we'll see if it prints fine at faster speed. And then that could be our new speed for printing everything, at least with this filament. I'm loath to change things because this is a really successful product, but I'm going to try it just to see if it'll work. And I'm going to print, once I'm done with printing this, I'll print these two things out again and and compare the quality of them and see if it's the same.
Alright, so here's our project. I'm running this in Simplify 3D version 5. I've got a lot of projects in version 4 still. I haven't moved them all over. just too much trouble. The automatic tool didn't work for me for the most part. So any new projects I'm doing over here, and a few old projects that I could use some of the benefits of this, which I showed in some other videos. I'm moving to version 5. So in any case, I figured, well, this is a new thing. I'll just use version 5. So this is set up for our G2, Guider 2. And here's our process. So let's look at the original one. Okay, so the original one we had for the layers, we had the first layer. Actually, this says 50%. For those dashboards, I was using 35%, so I should have done that already. But then the speed is 3,000 millimeters per minute. I did a lot of testing with PETG on my Dreamer NX, and I had layer adhesion problems if I went over 3,000. So, but again, I had some success running faster, so I figured I'd try it. So anyway, if we switch to the fast profile, layers are still the same, first layer, but the speeds I set to 3600. That's the speed I print PLA at. The other thing I did to help speed up some PETG prints is changing the travel speed to 6000 from 4800, which is the default and what I use for PLA. I didn't bother changing it for PLA because it doesn't really make that much difference, but every little bit helps on PETG. So anyway, we're based on these calculations, so let's go back to the regular one. And the print time says 54 minutes. Okay, but if we switch to the fast one where we're printing faster, actually a better test, let me change this one to 35, which is what I was printing my dashboards using. Yes, this is 56 minutes. Okay. And then we're not going to change that, but if we go to the fast version, here we're not going to change that. Actually, you want to change, yes. Okay, so now this is at 50%, which is what we want, and this is 3600. Okay, so if we prepare to print, so 52 minutes, so 4 minutes per hour faster just by printing the first layer faster and also printing everything else faster. Now let's check to see if we leave the speed the same but just change the first layer. So change this back to 3000. Oh, actually, well, yeah, we already did that. So if we go back to this original one, so this is printing at 3000, but then the first layer is 50% of the regular speed. So this is already 2 minutes faster. Okay, so we'll see. I'm not completely convinced that printing faster is going to work because I know I tested that a lot, but it's always better to question your assumptions. By printing the first layer, that's just all about layer adhesion or bed adhesion, and that seems to be fine on the other tests I did. So I'm pretty sure, in fact, even with this printer, so I'm pretty sure that 50% first layer speed is gonna help. So, all right, we'll save this to, which one am I on now? I'm gonna go back to the fast one. Yeah, we'll save this to the SIM card, and then we'll print it out on the machine and see what happens.
All right, so I'm still printing PETG at 237 and 60-degree bed temperature. That's been working great. We'll start that. I'll come over here to the filament temperature setting. I don't know why they have separate ones, but the Guider 2 has separate ones. Set that, and then we'll hit. Notice I'm using this stylus because this touch screen with at least with my finger, maybe my finger's weird, but a lot of times I like if I go here, I try to click filament, it'll say level. So it's just easier to use this stylus. This is just a blunt tool that I have lying around. So we're going to do leveling. We always level every day. As you saw in my earlier videos, with this removable print surface, I just have to level this once a day, and then the print surfaces are the same thickness, so there's no problem swapping around with having to re-level every time. I'm putting on glass. Here's my glass. I've shown that too. These two pieces of glass are not exactly the same thickness, which is annoying, but because I'm on the NX, I must have found this lucky and found two pieces that were exactly the same. Actually, you know what? I take that back because I did re-level after every print. Yeah. Okay. So for putting on glass, I have to re-level before every print because I'm swapping. In other words, I print on one piece of glass, put it in the freezer, and I put the other piece in and start printing it, the next thing right away, and not waiting for this to be done. So. All right, so we're going to do leveling. I've shown that before, so I'm not going to bother with that. And then we'll go ahead and print out our this guy. See if it's as strong as this one. All right, so we're ready to go. We're printing with a remnant, and the PETG wants everything closed up, so we're using our spacers back here, our wooden spacers. And here's the remnant wrapped around the feed tube. And the feed tube in here, I've shown on other videos, there's a sensor in here that tells you the filament ran out. You need to put, if you're going to use a remnant, you got to put some other filament in here. So this is a scrap filament I keep in the garage here, just to make the sensor happy. If the remnant was shorter, I was only putting out a couple grams, then I wouldn't bother with this. I would just have it hanging off the print head. But this is too much to be flopping around inside. So, all right, so we'll get this print started, and then I'll set up the time lapse. All right, there's our test. So 52 minutes. As you saw earlier, it's 54 minutes prediction for the slower speed. So we'll see how it works. All right, let's see how we did. Seems okay. Let's take it off of here and we'll clean it up and see how it turns out. All right, got it around the bench. Bed adhesion seems fine. So we printed the bottom at 50% of full speed instead of 35, which is what we used before. And we'll check the strength here. I can hear it cracking. Not quite as strong. So here's the original one. It's super strong, and this is cracking. All right, so I think we're going to. I think the only thing we're going to change is we're going to print the bottom at 50% of full speed instead of 25% or 35%. But I'm not happy with that. Also, the bottom seems a little spongy. So I think the higher speed printing is just not going to do it. All right, it's done. Let's see what the quality is. So the bed adhesion is very similar. I always take these off warm. Let it cool off. PETG, it sticks a lot more to the bed. So then I take it off and let it cool off over here. So it hardens up. But I want to take it off the bed when it's still warm. So I'm heating the bed to 60 degrees. So by the time I take it off and lay it on this wooden workbench, it cools off enough. It's 60 degrees. You can sort of touch. The actual surface is only 55, so you set the bed to 60, and because of heat gradient, the bed itself is only 55. And that's what I'm actually using. So it's okay to touch it, is what I'm saying. All right, let's get this off without messing it up. All right, so it looks okay. Let's look at the bottom. Remember, the bottom we printed at 50% of full speed. This is I'm still sticking with 3,000 millimeters per minute because that, as you saw earlier, the other test the layer adhesion wasn't good enough for my purposes. So, and the big one is fine too. They seem okay. So let's let these cool off for a minute, and then we'll check them out and see how they compare with the ones we did with the old settings. All right, these are cooled down enough. They should be at their full strength. I waited about 5 minutes or so. So it snaps on good, and it makes a complete set like the other one. Let's try it again. I heard you test it twice. Okay. So this is the same. So now here's the flexibility of the faster printing, and here's the flexibility and strength of the other one. I would say it's exactly the same. Here's the strength and flexibility of the bigger one. And this one, I'm not hearing any cracking. The resistance to bending is about the same. It is flexible, but it's not going to crack. So, all right, so this is a winner. So printing this versus printing this was 14 minutes faster. Part of it was the first layer, 50%, but then I'm printing this in 2 processes, and as I sometimes do, I just copied the lower process. So for the bottom part of it, I'm printing it at a certain. I have a setting for the first few layers, and then I have another process for the upper layers. And I had copied the process for the lower layers and left in the 35% speed for the first layer of the upper layer. So I had two layers where we're only printing at 35% speed, 30% of normal speed. So by changing both of those to 100%, or to changing the one on the bottom to 50%, and the one as I'm already printing to 100%, because I'm already printing, I don't need to slow down that layer. I may put this by 14 minutes. So it takes about, let's see, 4 of these. I have other pieces that take a bit longer to print. These take about, they were taking 3.5 hours. Now they're taking 3 hours and 15 minutes. And so the other pieces take longer. I have to print a total of 4 prints per day, so it's pushing 15 hours total printing time. So now I should be able to save at least an hour per day, which means I'm not. It's going to be easier to complete a full print, which is a half set of these in one day, is what I'm trying to say. So with the Guider 2, I can print PETG first layer 50% speed of regular speed, and I use 0.9 or 90% first layer height, and first layer width of 100%. I get good bed adhesion with the temperatures I mentioned earlier, and but you don't want to print it as fast as PLA. So 3,000 millimeters per minute is what I found I can do with my printers. So those are my recommendations for PETG. So this is a very successful experiment, and always trying to improve things, make things print faster, makes productivity increase.
If you like this video, please give it a thumbs up. Post a comment if you have any questions or ideas, and I'll try to respond. That's all for now, but more videos are coming, and if you want to see them, please subscribe to my channel and turn on the notification icon if you don't want to miss one. This is Beta Cygni signing out, and keep looking up.